Let's do 6 and 7 in one video. They're closely related. So 6, determine whether the outcome is a type 1 error, type 2 error, or a correct decision. Okay, let's talk about type 1, type 2, correct decision. I'll present this, and then at the same time I'll present it using a situation that hopefully makes sense. Guilt and innocence, right? Let's say a person can be innocent or a person can be guilty. All right? This is how I always construct this chart here. And as we go through a trial, we can either acquit that person, like release them, or convict the person. Say, yeah, we believe you're guilty. You're going to go to jail or face your penalty or whatever the penalty is. This is real life, right? If we're talking in terms of hypothesis testing, person innocent, that would be the null hypothesis is true. Person guilty, the null hypothesis is false. Acquit will be we reject the null hypothesis. Convict, we do not reject the null hypothesis. And as I'm saying that, I realize that doesn't make sense what I just said, so I'm going to change these two. My bad. This will be convict, and this will be acquit. Sorry. Okay, cool. So if we convict a person who's innocent, that's pretty bad, no? That is what we call a type 1 error. That's an error, right? That's a mistake. You're not supposed to convict an innocent person. That's silly. You convict a guilty person, you made the correct decision. You acquit an innocent person, that's what you're supposed to do. If somebody's innocent, you let them out, right? Correct decision. But if you acquit a guilty person, if you let a guilty person go free, that's also an error. That is a type 2 error. And these errors occur in hypothesis testing, and we use these significance levels to showcase the type of error that we're accounting for. I'll say it like that. Okay, so in hypothesis testing terms, if you reject the null hypothesis, if you reject it when the null hypothesis was actually true, you've made an error. If you reject the null hypothesis when it's actually true, you made a type 1 error. If you do not reject the null hypothesis when it's not true, right? You should have rejected it, but you didn't. That's the type 2 error. So let's check out this situation here. So the test is, the null hypothesis is population mean equals 13. Alternative hypothesis is the population mean is not equal 13. So this null hypothesis is either going to be true or false. We have to determine whether it's true or false. So here's what happens. Here's the real thing now. Population mean is 12. Is the null hypothesis true or false? Is the null hypothesis true or false? Well, we said the null hypothesis was 13. The null hypothesis is that the mean is 13, the population mean is 13. Population mean is actually 12. So the null hypothesis is false. So we're here. The null hypothesis is false. The correct decision would be reject the null hypothesis. Right? So if the true value of the population mean is 12, we see the null hypothesis is false, right? Because it says the population mean is 13. So if the null hypothesis is false, we should reject the null hypothesis. But this says we do not reject it. So we've made a type 2 error here. Okay. I'm going to cut this. Use that tool. Select this 7. Paste it. Okay, I think I can squeeze it there. All right, here we go. So a fleet of rental cars, all the same make, model, and year, has a mean fuel efficiency of 25 miles per gallon. So that's the population. We take a sample of 40 cars, and the air filter is replaced with a new one. So we did something, right, for these 40 cars. Let mu be the population mean fuel efficiency score that would occur if every car's filter were replaced. The air filter change is deemed effective if the population mean is greater than 25 miles per gallon. So if we get, so let me write that. Population mean is greater than 25 miles per gallon. That means effective. A test is made. So the hypothesis test is the null hypothesis is the population mean is 25. Alternative hypothesis, the population mean is greater than 25. So now, this is the situation. Now we need to determine, is the null hypothesis true or false? Assume that the air filter changes are not effective. Air filter changes are not effective. Okay, beautiful. So if the miles per gallon were greater than, if the population mean is greater than 25 miles per gallon, that's an effective change. But the air filter changes are not effective. So that means we're not greater than 25. That means the null hypothesis is true. See, the alternative hypothesis said the population mean is greater than 25. If that was the case, if that happened, we would have an effect, the air filter changes would be effective. But since they're not effective, we know that the alternative hypothesis is not true. Null hypothesis is true. So we're here. So if the null hypothesis is true, there's only two possibilities. Either we make a type 1 error, or we made the correct decision. If we reject the null hypothesis, that's an error. Do not reject, that's the correct decision, because the null hypothesis is true. So which type of error is impossible? Type 2 error. The answer for both these questions are type 2 error, but answering different questions, right? Type 2 error is not possible in this situation because the null hypothesis is true.